Use low resistance cable to reduce power loss. And then electrical fuse must have a low melting point and must be connected to live terminal. Question 1. Just adjust it. Adjust. Is it not working? It should work. Or who's test student, they find it not work in the night. It did not work. You can leave if it's not, if you are not getting it. Just trying to consider the heat. It's much today. Right, question 1. In the wiring of houses, just for us to document it, all of you know the answer. In the wiring of houses, come on. In the wiring of houses, come on. The fuse is connected. The fuse is connected. The fuse is connected to the. The fuse is connected to the A. Daniel, come and pass the front. If you are going to the top floor, that place is blocked. They are late commands. They can't write exam. I told them. In the wiring of houses, command, the fuse is connected to the A, earth terminal, earth, E-A-R-T-H, earth terminal, B, neutral terminal, neutral terminal, C, live terminal, option D, the three terminals, Class, what's the answer? You will have life, amen. Point 2. A 12 ohm resistor. A 12 ohm resistor dissipates. A 12 ohm resistor dissipates 8 kilojoule of heat. A 12 ohm resistor dissipates 8 kilojoule of heat. 8 kilojoule of heat in 20 seconds. A 12 ohm resistor dissipates 8 kilojoule of heat in 20 seconds. 8 kilojoule of heat in 20 seconds. Full stop. Calculate the current through the resistor. 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 Or your classwork. Don't forget the formula on the board. Energy is I squared RT. So quickly solve it. Then convert your kilojoule to joule. Energy is I squared RT. Energy I squared RT. Anyone true? Convert the kilojoule to joule. Are we giving resistance? Okay. We're looking for current. So our energy is I squared RT. How much kilojoule are we given? 8 kilojoule. Energy, what's energy? 8, that's 8,000 Abi. We have I squared. What's resistance? 12. What's time? 20 watts. So we have 8,000. Will now be 240 I squared. So I squared will now be what? 8,000 over 240. Calculator, what do you get? I can't hear you. 33.333333. Abi, our I will now be square root of 33.33333. What do you get? 5.77. Thank you. Amperes. Next question, number 3. Number 3. A potential difference of 12 volts. A potential difference of 12 volts. A potential difference of 12 volts is applied across the ends. Is applied across the ends. Is applied across the ends. Is applied across the ends of a 6 ohm resistor. Across the ends of a 6 ohm resistor. Across the ends of a 6 ohm resistor for 10 minutes. For 10 minutes. For 10 minutes. Full stop. Determine the quantity of heat generated. Determine the quantity of heat generated. Determine the quantity of heat generated. The quantity of heat generated. Classwork, I won't give you the formula, you know it. Write out what you are given. What am I given? V. Okay. What again am I given? I am. Then you look at the formula I gave you. Raise your hand. Very good. We are giving voltage. How much? Are we giving current? Are we giving time? How much time? We convert Abi. That's 10 times what? How much would that be? 600 seconds. Are we giving resistance? How much? 6 ohms. So our heat energy is V squared over RT, Abi. So please know the formula for energy. Know it too. That will be 12 times 12 times 600. All about resistance. What's resistance? 6 here, 1 here, 100. 14400. 14,400. Is that your answer? Joules. Question 4. An electric generator. Question 4. An electric generator. An electric generator rated 12 kilowatts. An electric generator rated 12 kilowatts. An electric generator rated 12 kilowatts, 2 kilovolts. Rated 12 kilowatts, 2 kilovolts. Distribute power through a cable. Distribute power through a cable. Distribute power through a cable of resistance 20 ohms. Distribute power through a cable of resistance 20 ohms. Full stop. This thing is not growing at all. Calculate the power loss in the cable. Power loss in the cable. Already the power loss in the cable. Now, what formula for power loss? I squared R. Yeah, go and look for I first. Look for I. From the first two statements, you can find I from that place. They give you 12 kilowatts. They give you 2 kilovolts. From there, you can find I. There we go. Pardon. Borrow me calculator. Now so now they do since if you buy one. The what? They give us power. They give us power initially. What was the power they gave? How much? 12 kilowatts. How much voltage? 2 kilovolt, Abi. From here you can find current. Do you know? Power is VI. If you don't like VI, right? Lagos Island. So V, our I now be P over V. What was that P? 12 kilowatts. What was that voltage? 2 kilovolts. What is 12 over 2 going to be? 6 amperes. Now the power lost. Class formula for power loss is I squared. Don't forget to. What's your I? 6 squared. What's resistance? 20. So that'll be 30 resistance 20. 720, right? 720 watts power loss. That's why to minimize power loss, you have to use cable of low resistance and then transmit that high voltage, low current. Number what now? Number 5. We have the following statements. We have the following statements about a 3-pin plug. To the following statement about the 3-pin plug is or are correct. To the following statement about a 3-pin plug is / are correct. We have the following statement about a 3-pin plug is / are correct. Number 1, the brown wire is the live wire. Number 1, the brown wire is the live wire. The brown wire is the live wire. Number 2, the fuse is connected to the live wire. 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 Number 3, the earth wire is color blue. The earth wire is color blue. The earth wire is color blue. I won't tell you the options A, B, C, D. You are the one that will combine it yourself. So get one answer. You just write one only, 2 only, 1 and 2, 1, 2, 3, 1, 3, 2, and that. Have you got your answer? What's number 1? Is that correct? What's number 2? Is that correct? What's number 3? Is that correct? No. So what's the answer? I and I only. Number what now? The electricity meters. The electricity meters in houses measure energy units consumed in. The electricity meters in houses measure energy units consumed in. The electricity meters in houses measure energy units consumed in. Option A, kilowatt hour. Kilowatt hour. Option B, joules. Joules. Option C, ampere. Ampere. Option D, coulomb. Option D, coulomb. Class, what's the answer? Kilowatt hour. Number 7. A lamp rated 400 watts, 240 volts. A lamp rated 400 watts, 240 volts. Is lit. L-I-T. For 1 week. Is lit for 1 week. Full stop. Calculate the cost of lighting the lamp. Calculate the cost of lighting the lamp. Calculate the cost of lighting the lamp. If 1 kilowatt hour of energy. If 1 kilowatt hour of energy. If 1 kilowatt hour of electrical energy costs 50 naira. If 1 kilowatt hour of electrical energy costs 50 naira. You should be able to do it, but let's do that. That's the first time I think cost today. Oh yeah, we have electrical energy consumed. Electrical energy consumed. Don't forget, we have just mentioned that it must be in kilowatt hour. So that will be power times time. How much is the lamp? How much watt is the lamp? 400 watts. So you must convert to what? Kilowatts. So that 400 watt will be 0.4 kilowatts. Do we agree? Convert to kilowatts. 0.4. What is the time? How many hours? How many days? 1 week is 7 days, Abi. How many hours per day? So we're going to have 24 times 7 hours. So it can be kilo. Don't convert to seconds, though. 7 days make a week. 24 hours make a day. So you have this. Calculator, you multiply the 3 of them. So 7.2 kilowatts. How much is 1 kilowatt hour? Are we given? How much? 50 naira. Therefore, they have increased tariff in Nigeria now. So 7.2 kilowatt hour would now be 67.2 times 50 naira. That's all. That's 67.2. Calculator, what do you get? 3,360. 3,000 naira, 360. 3,360 naira. Next question, let's move. Question number what? Classwork number 8. Two lamps rated 100 watts. 2 lamps rated 100 watts and 250 watts. 100 watts and 250 watts are used for 10 hours. Are used for 10 hours. Full stop. Calculate the cost. Calculate the cost of lighting the lamp. Calculate the cost of lighting the lamp. If electricity costs 200 naira per kilowatt hour, 200 naira per kilowatt hour. Plus work. 200 naira per kilowatt hour. Electricity costs 200 naira per kilowatt hour. Class work. We're having an exam this week. Raise your hand. Friday or Saturday. All those hands you will score above 300. By the grace of God, God will help you. Don't be afraid. Just keep on pushing. Keep pushing. So some people are true now. You are true, raise your hand. Very good. The first thing you find, total power. Total power. The first lamp, how much? Second one go. Add the two of them, what do you get? 350 watts. We convert to watts. So that will be 0.35 kilowatts. Electrical energy is power times time. Electrical energy, PT. How much power do we have? 0.35. How many hours? So what would that give us? 3.5 kilowatts hour. How much is electricity, class? 20 naira. I think you're on your own. 1 kilowatt hour. You eat alone, you die alone. That's the slogan I've learned from you. 3.5 kilowatt hour will now be 20 naira times 3.5. Calculator, what do you get? 700. Question number what? About 9. 9. A device consumes 100 watts. A device consumes 100 watts of power when connected to a 120 volt source. A device consumes 100 watts of power when connected to a 120 volt source. 120 volt source. Full stop. Calculate its resistance. Calculate its resistance. Calculate its resistance. Class work. Class work. Help me wake Deborah there. She has been sleeping since. Help me wake her. If she's not waking, you slap her. This is week of exam. I pray she will not go and sleep in the exam hall. Yeah, she sleeps every time. And she has not come to meet me for help and say, "Sir, I don't know, there's one issue that I want you to help me with." It's a lie. She'll be arguing now, I'm not sleeping. I'm not sleeping and you are not writing. Because when they be sleeping in few minutes to war time. Exam is here, you are sleeping. Why? Are you true? What's the answer? 1. So we're going to have power whatever PR is V squared. Our would be V squared over P. What's the voltage they give us? 120 times 120. And what's the power? 100 Abi. 144. Is that your answer? Okay, Prof is here. Last question, number 10. Probably coming before you get to the board. I'm true. What the following is a function of the fuse. The following is a function of the fuse. The following is a function of the fuse. Option A, it regulates voltage. So the following is a function of the fuse. Option A, it regulates voltage. It regulates voltage. Option B, it prevents excess current from flowing in the. It prevents excess current from flowing. It prevents excess current from flowing through a device. It prevents excess current from flowing through a device. It prevents excess current from flowing through a device. Option C, it prevents electric shock. Then D, it allows sufficient current to flow. It allows sufficient current to flow. It allows sufficient current to flow. Class, do you know the function of a fuse? What is the function of a fuse? Electric shock or load. Is that what fuse is all about? It prevents what? Excess current. It limits the amount of current flowing.